talked a lot about software, how software is changing the industry. So sometimes we have to think about the existing industry, especially cars. Would you buy a car by a person that is quickly shipping a car a day that just build it up? No, of course not, because there are regulatory requirements. So you wouldn't buy a car from those people because you feel you need to be safe when you're driving. In case of an accident, you know there's some kind of insurance, and that's great. And that is something that you want to ensure all the time. That's why companies, when they ship a product, they need to ensure it continuously before they even deliver it to the market. So now think about it. So we can use that in software as well. And we call that test-driven infrastructure. So Chef has a long time history in testing infrastructure. You may know Test Kitchen, Spec, and Chef, and how easy it is. And let's take this session to see how we can apply that on an operating scale. So I'm Christoph Hartmann. I'm engineering lead for Chef, especially compliance. And we are going through that session today about a company, a use case that we had that is especially a retail company. It's doing a lot of payment on point of sales, online sales. So they have a lot of regulatory requirements, especially about PCI. So who knows PCI? Oh, quite a lot. So how excited are you? So that's interesting. So then you're maybe familiar with those documents, right? So those documents explain in detail what you need to verify. They explain, hey, in this case, you make sure that you apply some industry-wide accepted hardening guidelines to your machine. Sounds easy, but it's hard. So that's pretty standard. Let's take another requirement that was published last year and was first due until June of this year, but has been moved for 2 years because it was so hard for the industry to adapt that. That is the move from SSL to TLS version 1.1 or 1.2. So let's think about that and how hard can it be. So on top of that, we have to think about this specific company. It's not a software company by itself. It's doing like a hardware product. So they have already on-premise, they have cloud, parts of it are deployed with Chef, parts are not. So you see the orange boxes are deployed by Chef, the gray ones aren't. So on top of this, we have different teams that need to come together to make this happen. So we have the DevOps team that is deploying software, and we have compliance and security departments who need to make sure that everything is in place. For example, compliance is responsible for PCI, but security is responsible for the security of their web servers. So if we take a look on the existing infrastructure and how they deploy it, they already use Chef. They use different tooling for testing and development. For example, they use Spec on the development side. They use linting in the CI/CD pipeline, and some security tools on the production side. So it's quite challenging to bring those things together. Keep that in mind when we continue. So management came up and said, guys, I know you have different responsibilities, but this is my agenda. So verify that CRS benchmark is ensured, apply CRS hardening to your servers, then verify that TLS version is, so at first find out all those servers that are not compliant, and then just remediate that. Sounds easy, right? So let's do that. So that's the task list for our talk, and we worked through that. So luckily, we have Chef Compliance available. So that is shipping with a bunch of CRS profiles that help us a lot to achieve that. So we do a quick scan with Chef Compliance to see how that is working out. So we just see our nodes here. We have a new node, hasn't been scanned before. We can see, hey, yeah, we can connect to that. So that is all remote. We don't need to install an agent for that. And once we have that, we just click on scan for patch level. In this case, we select the CS CentOS profile, and we run a scan. So that helps you to easily find issues in your infrastructure, no matter how they are deployed, which is great because now you have an overview about the whole infrastructure for your compliance perspective. So that you see that is a lot of tests, so it takes a while. So that's good. So we are not good because we see a lot of critical issues. So that is great. But to see how we continue that, and we are talking especially about test-driven, UI is great, but we need to integrate it somehow on a CLI level. We need to integrate this into our CI/CD pipeline. So we need to have a way to automate that across your chain. So now we have the same capability via our CLI to InSpec, which is our engine, our compliance testing engine, also behind ChefConf. So this is our CLI. It offers a lot of commands. You can just easily use that from command line, pretty straightforward. So in case you haven't seen an InSpec test, so the test.rb looks like this. It has a describe block, SSHD config, protocol should be version 2. So that's the same language that we use to write all those CIS compliance profiles. So you can easily execute that on the command line, and then you get the response. So if we take a look on compliance, on top of the test that we use as a describe block, we add some metadata to it. So it's the criticality, title, description, and that helps you to share the same test across different departments. Because now, even if you don't understand the code, you can just understand the text and the description. So the cool thing about InSpec is you can run it on like nearly every SSH-capable machine. You can run it on Windows. You can run it against the Docker container. And you don't need to install anything on those machines. So WinRM, SSH, or Docker are essentially everything you need to do that. So let's have a look at how that is working out on the CLI. So here we make sure that we have a machine up and running. So it's a fresh machine that we just provisioned. And what's happening here, it's a plain machine. The CentOS 7 machine, as you see, and we will run the same compliance test that we have seen before in Chef Compliance from the command line. So what we do here, we output now all the profiles that are available in Chef Compliance, and we can easily use that now on the command line as well. So we type in InSpec execute, compliance, and then select the profile that we are going to use. In this case, again, CentOS 7. We type in the SSH credentials. So this is like using the regular machine, the IP address, and the SSH key. So once we have that, we run that same kind of test that we have seen from the UI perspective on the command line. And that is now a lot to execute. So that takes a while, so take a rest. And once we have that in a second, we can continue on that. Great. So now we see a lot of failures, as we have seen in Chef Compliance. But now you see you can run it on the command line. InSpec offers JSON input and JSON output. So what we see currently as a CLI human readable output can be also retrieved via a JSON file. So the question now is, how can we remediate that? Because we have seen, okay, we cannot scan it. So the question is, how can we solve that? And there are two awesome cookbooks out there. So one is available from Chef Cookbooks, and we have also the USGS cookbook out there. So what we're doing here is we provision a regular machine with this cookbook, and then we run. I skipped that phase. I will publish it later. But essentially what we want to do is we want to run it in test kitchen. So that means we have a continuous cycle. We can continuously see how that works out. Let's make it smaller a little bit. So what we are doing here is we open our background machine, we select the recipe, so in this case you see it's the default recipe from the hardening cookbook, and we reuse the same profile as you have seen before in our test kitchen environment. So that is different from what you have seen before because server spec tests always had to be located within the cookbook, so now they don't. So that makes it really easy to compose local infrastructure testing with compliance rule sets that are maybe governed by another corporate division. So let's see how that works out. So this is how it looks like. We have the kitchen file, pretty straightforward, no surprises here. And we have a plain machine, so that's just quickly created. So you see here we have Chef Solo and InSpec combined with SSH. And we execute now converge that is running the hardening cookbook and ensures that everything should be all right at the end. Because that's what we expect when we run a hardening cookbook. So that takes a while, so it's now configuring everything that is required. And this is really powerful, because once you have this cookbook available, you can not only do it in one machine, but you can also run it across your fleet. And by using that in Test Kitchen continuously, you can pull in also external public cookbooks and verify it continuously against your own guidelines or the CS guidelines. So what we now do here is we run the verify phase, in this case explicitly. Normally you would run it with Test Kitchen test, so that you have the full cycle. But in this case, it's better to illustrate it in a manual way. So again, it's pulling the same profile from Chef Compliance. It's running it against the cookbook. And we see, okay, it's much better, so only 40 errors. But still we see, although the cookbook claims it supports everything, it's maybe not everything that you should have in your production. So in this case, I can tell you that's mostly some like mapping with the file system that temp directory should be mounted. And this is not covered by the cookbook, which is all right, but you have to know that. So that's great, because now we can continuously test our cookbooks early on against compliance rule sets. And think about compliance as a quality gate. So it's not something that slows you down. Now it's something that enables you, because you can really discuss all those issues early on before we even deploy it. So you don't want to have it late in your deployment stage. So now it becomes more complex. So we have this TLS version 1.2. So again, we need InSpec for that to see how can we do that. So we want to have a resource, in this case SSL resource, to verify that something is properly configured or not. The problem here is InSpec, if you know the project, it has nothing included to cover that open source. So when we tackled that problem, we were thinking, okay, how do we do that? And we used our own extension mechanism to write custom resources. So whenever you tackle a problem that is not yet covered, you can extend InSpec easily to cover that specifically. So in this case, think about an SSL resource. You give in a host and a port and run an SSL test, and once it's successful, it says, oh, all right. So InSpec profiles gives you a great possibility to write those custom resources. Annie, who's also sitting over there, has written a great blog post about that, so I recommend to read that because I have no time to do that right now. So what we want to do at the end is not only to figure out, okay, we have that problem now, but we want to also remediate it. And this is something that we see now, where we run InSpec to see the SSL profile running. So we have here now an insecure rule. That means it's just nginx and our SSL application. So essentially, it's just a website published to an nginx server. So we deploy that quickly. And that is without anything specific. It's plain Ubuntu, plain nginx, and plain SSL configuration out of the box, nothing special. So once we have that, we run our SSL test against that, and let's see how our system behaves. And that is not like easy to see out of the box. So as you see, the chef run is going, it's installing nginx and the application. And once we have that, we know that's our production server. So although it's running in Vagrant, think about it, it's your production server. It has a current setup that you may not be able to change, but that is something that I'm going to use for illustration perspectives, because now we run the SSL profile and we see the out-of-the-box configuration is showing us that TLS version 1.0 and 1.1 is still active, and we don't want to do that. So SSL was already disabled, so it's not too bad, but not perfect. So now we include a couple of hardening cookbooks. It was OS hardening and the SSH hardening on top of the nginx hardening. So here you see we activate only TLS version 1.2. So now we provision that same thing. So we use the existing server and run hardening on top of it. So the application was already deployed beforehand. So that is the case that I'm going to prove here, that we now extend and reconfigure an existing server with the hardening guidelines. And by doing that, with Chef, you can now also test it properly if you use it in Test Kitchen. So you can run it locally, so you can still combine it with your infrastructure test, so that you're always able to say this application works no matter if hardening is applied or not. So you see, it's working now great. So that's something that is not easy to tackle normally. If you have the SSL example in your infrastructure, you normally see, I don't even know where SSL is running in which version on which machine. So by having this profile now available, you can run it across the whole fleet. That works now. I was looking for that. So again, the same profile that we've now been able to run from the command line, we can run the same also from Chef Compliance, since InSpec is the base foundation of that framework. So we had here a server before that was just configured insecure. We used Chef to fix that, and now we are able to see that in Chef Compliance as well. So that allows us now easily to run it from command line, run it from the UI, and it's really easy to spread that knowledge now across your teams. So from management perspective, back to our original PCI checklist. So what we have seen just in a couple of 20 minutes, was we verified CIS benchmarks, we applied CRS hardening, we verified the TLS ports, and we migrated and falsely configured nginx through properly configured nginx server. So think about that. So about the timing that we've used to do that. So back to our test-driven infrastructure to make this what has that to do together. So now we have InSpec on all chains. So we have InSpec in the development pipeline, in the staging environment, and in the production environment. And that, as you use Chef, we now be able to use InSpec across the different stages, and that enables you to reuse the same testing across your infrastructure and across different teams in your environment. Because if you use infrastructure testing with InSpec, it's great. You don't need to use the compliance part. But now security and compliance departments can define their rule set in code as well. So that's now a language available at your hand to ensure that you have an artifact across teams that you can manage as before with Chef. So think about infrastructure as code, now compliance is code. So that's great. So InSpec is essentially the language to define it, and that enables you to make it extensible. We use the same language to define all our compliance profiles as well. So whatever you write is using the same framework than we do. So we use the same extension mechanisms, we use the same underneath Ruby code, and in case something is missing, you have Ruby at your hand to extend it. That's pretty powerful, and you can integrate that in your CI/CD pipeline. So if you use Chef Delivery, you've seen great UIs already this morning, but it's also working in other CI/CD pipelines. So the workflow that we have here, you can scan for compliance, you build it locally with Test Kitchen, you verify that everything is running. Then you build it into your CI/CD pipeline so that every change that is now coming to Cookbook is continuously verified as well. So you will never ever deploy something in production that is not compliant once you establish that use case. And of course, we use Chef or any other configuration management to remediate, and at the end we can verify it. So that's becoming a cycle, and it's enabling you to make compliance a core part and testing a core part of your infrastructure to enable quality at the end when you ship software to production. So when we think about our company, so now the teams are aligned, they can work together, they can define the goals together, they can now cover servers that are on-premise, servers that are in the cloud, servers that are managed with Chef, servers that are not managed with Chef. So that's a great mechanism available. So we think about continuous testing, but it's also continuous compliance, and that is enabling you to cover that well. So I'd like to thank you and use the last part to cover a lot of discussion about that topic. Great.
How do you test through a Bastion host? Because right now, on the demo, you showed that you can go to SSH, but for me, I've got to go through Bastion host to then hit my EC2 instances.
Yeah, that's a great question. So we have the outer cookbook available for that, so you don't need to do it. The question was about, is it possible to run it on a Bastion host where we have no ability to connect via SSH that host? Is that right? Yeah. All right. So the challenge here is that, as you're seeing, Chef Compliance is using remote connectivity to that server. So we recently, in March, we published a plugin with Chef Server, so you can connect it to the Chef server easily. So that means you can now use every node that is already in Chef. You run an audit cookbook, you just define the profile. Let me quickly open that audit cookbook. So that is available. So here you have two options. Essentially, it's running the Chef client via the Chef server and reporting to Chef Compliance, or you could run it directly with Chef Compliance. So both things are available. So you can use the same profiles as you've seen for SSH, and you can run it now with Chef Compliance via a cookbook. So that enables you to have like air-gapped environments that you already use with Chef, and just run an audit cookbook on top of that. It's pretty straightforward to configure it. You have the profiles, you use like the same mechanism that we have seen on the command line. And finally, the report is looking the same in Chef Compliance. So there's no difference. Yeah?
What other than the audit cookbook do you need? Do you need that plug into the Chef server or something else?
Okay, the question was, do we need a plugin for Chef server, anything else than Chef server on that node? So essentially, you can use the Chef server integration, and that makes the life a lot easier because that is connecting you to the node and synchronizing the nodes automatically. No matter what, you can also say, I don't want to do that. I have only Chef 0, for example, I don't have a chef server, so you don't need anything except the Audit Cookbook. So the Audit Cookbook is installing the latest version of InSpec on that node, and then it's pulling that profile from Chef Compliance and reporting it back to Chef Compliance as well. So that's using access credentials, access token credentials to do that. In case you use the Chef server integration, you need to configure Chef server properly, and you need to connect Chef Compliance to that. That also enables you to say, I don't want to have like 2 user credential systems. Now you can use the same credentials in Chef Compliance as you do in Chef server. So that synchronizes the user, the nodes, and makes life quite easy. So we have a lot of companies that use that setup to cover that case.
So you showed the example of chef hardening where it actually, I guess, disables TLS protocols for nginx. I mean, what is that actually doing? Won't the next chef converge undo it if you have cookbook recipes that are applied to template or something?
So in this case, the question was, what have we changed to make this nginx change happening? And that is a cookbook that is also available on GitHub, github.com. So that is Chef nginx hardening. And here you can see what we are doing. So that's now changing essentially the configuration of the original nginx cookbook. So think of it of a layered cookbook. So that's overriding attributes that are not secure, and it's also injecting the configuration properly to the nginx cookbook. So it's not a separate cookbook by itself to say it's completely independent. In contrast, it tries to use the open community cookbooks, embrace it, and just do the hardening part. Because that makes sense if you have a development environment. So you may want to have more access to it, you want to play around, and you want to only activate it in like production environments. So that's why you can look it up what it's doing, but it's working essentially hand in hand with the original nginx cookbook, and that makes life a lot easier. So the DevSec.io cookbooks, except for the OS hardening cookbook, are an overlay cookbook. So they try to use their attributes available as much as possible and just rewrite them if required. But it is not doing anything magic. So everything that is happening there is documented well. So you can easily follow that. Yeah.
As we move into an environment where engineers have more and more control, one of the things we look at is containers.
Mm-hmm.
You just treat it as another host? Is there anything?
Containers are interesting because they are properly supported by InSpec, so you can easily do that. Let's try that. So we have, let's run a new container, IT bash. Oops. Okay, so this is now running, so let's see. So we can now, let's execute an example profile. Example profile. Docker. So that is now, you've seen I just spun up a plain Ubuntu machine that's running on that. So let's say from an InSpec perspective, from the base perspective, it's no problem to cover containers. So when we think about compliance in specific, that is becoming more challenging. Especially since all those compliance guidelines that are available are optimized for a default operating system that is like running on normal bare metal server. So containers normally have a minimal operating system. So a lot of components like grub, for example, are not available. So that means that is something that needs to evolve. That is something that the industry needs to adapt to. And it's not something that Chef itself can answer. We can help drive that discussion, but it's up to CRS and industry bodies to find a good way to do that. So we normally work with external auditors to define the hardening guidelines. We are not the person or the body that is saying this is right or this is not right. So this is something that we're currently driving, and we work with federal agencies in US that are like doing government research, and they do a lot about containers as well. So they drive that. We have also industries, big corporations like banks, for example, that go forward with containers, and they struggle a lot with compliance on containers. And that is not only caused by the compliance profiles, but also the tooling is not available. So they are really happy to see InSpec natively supporting Docker and embrace that. And now it's challenging to define the rule set for containers because they are really limited in the scope. They may have are optimized for specific use case, and that's why Habitat is interesting here, because Habitat is now including a lot of information about the application and how it is composed, and this is something that we work on in InSpec to also cover more of the application security. So far, we have seen it's all operating system configuration, right? So it's like base operating system, so that's what we are used to. But on top of that, we are covering now soon the application security, but also infrastructure security from cloud perspective. So there's an InSpec AWS available that allows you to verify security groups as well. So let's have a look. InSpec AWS. So that is something that we will embrace a lot further in the future. And just to give you an example how that works, it iterates over all security groups, verifies that all security groups are properly configured. So that enables you now to not only verify a node, but also going forward to the application and also going forward to the API level. And that is where compliance is heading. And this is also where testing is heading. We have seen a lot of companies, they now say, we don't deploy anymore in an environment where we just have a couple of servers. So instead, when every time we roll out a new application version, we configure a complete new AWS account. So that is challenging from the compliance perspective and testing perspective, because how do you get that under control if you change the infrastructure that fast and that hard? So that's something that needs to be covered by testing to enable stability. And this is something that we are heading forward with the whole framework to enable you to define whatever is required and to say, this is the state I'm expecting. And then you can verify it. You've seen Test Kitchen and it allows you to verify it on the operating system level. And we need to see how we do that with AWS or applications. Yeah.
I saw in one of your early slides, Windows coming soon. Is there a date?
So you're talking, the question was, is there any Windows support for InSpec or Chef compliant? That's a great question. Thank you. Yes, there is. So Windows is well supported already in InSpec. So we have it in, let's see. Let me quickly fix that. So Windows is well supported. We have a base profile already available. What we are going to do is we will ship a CRS profile for Windows within the next weeks, and that allows you to say, as you use with Linux, to run it across your Windows fleet. We have also started investigating a lot for Microsoft SQL Server and IIS Server. So a lot of companies are requesting that, and it's in our pipeline to do so. So while I'm doing that, to show you that's working in Chef Compliance, any other question? Yeah.
Is your slides going to be available?
Yeah. So my slides, inclusive all the videos, are available soon. Follow me on my Twitter account. So it will be, I think, available tomorrow latest. So that enables you to show it also within your corporation or organization, so that you have a follow-up. Also, I will publish and reference all the examples that I use to do that. So how to run, for example, the nginx example, and how to fix that configuration so that you can easily follow that. I also reference, I recommend to take a look on DevSec.io. That's covering a lot of hardening. Annie's blogs have been great about InSpec if you want to learn InSpec. And a couple of great cookbooks are here available. I like to thank the USGS guys for the Stick cookbook, and also Schubert Phillips for the Let's Encrypt cookbook. That's thanks. That is used in my examples. You can follow that, and that enables you also to run a properly configured server, set it up from scratch with a good SSL certificate. So that I think is something that makes it a lot easier to deploy it in production. So let's see. So the profiles that we have here are, we have two pieces. Back to the Windows question. So we have Windows Server baseline security available, and we also allow you to import profiles from Microsoft Compliance Manager. So you can export to System Center and import that System Center part. It's not yet well documented. If you need that, ping me or any other Chef employee, and you get access to that. So that helps a lot in production. Anything else? Yeah.
How do you export these profiles to use them outside?
So the question is, how do I export the profiles from compliance? So currently, those profiles, so this is something that we just covered over the last days, that people want to use that profile locally and have a look onto that. So currently, InSpec is streaming that information. So if you run an InSpec compliance locally, it's streaming it from the server, and it's not placing the files locally. It's all done in memory. So therefore, you don't have the download capability yet. You could use the API to do that, but it's not yet on the InSpec CLI. So let's have a look at Chef Docs. It's pointing to. So here we have. Oh, that changed.
So you cannot use InSpec without compliance?
You cannot use InSpec without compliance. Of course, you can use InSpec without compliance. The only thing that will not be available is all those CS profiles. So the CS profiles are part of our commercial offering. The InSpec is the engine, and there's no difference between InSpec shipped underneath of Chef Compliance. So that is the same InSpec version, and you can take a look on how that's done. So that means all the capabilities are offered to Chef Compliance then. And the reason for CS that we are not making this open source is because Chef is paying for that as well to be a CIS member. So that is like also costing us money to ship that and to continuously support that. So that's why we are not shipping that open source. But as we said, we have an integration into Chef Compliance, so you can easily pull that locally. On top of that, I'd like to highlight that we have a couple of profiles available on the supermarket. So, and that's also something that you can use from InSpec. InSpec has a supermarket plugin. In case you're confused over B, it's bundle exec, so you don't need that if you install it on your machine. So we have here the InSpec supermarket. Let's see what it's InSpec supermarket. So that shows you, okay, we have a couple of options to see from the supermarket. And in this case, let's have a look on the available profiles. So now that's connecting remotely to the supermarket and showing those profiles locally. So if you build a profile, you can easily use that to share it. And the good thing about that, you can now say, let's run the SSH cookbook locally. I can say inspect exec supermarket and run that profile. So I don't need to take the hassle to download it beforehand, to find it, and to upload it somewhere. So you see, I just typed in the URL. It's pulling that directly and running it locally. So that's how easy it can be to run those. Yeah. So one other profile that I may highlight that is maybe of interest for you if you want to write something. There's one CRS, DevSec. The CRS Doctor Miracle. So that's a very good example profile that you may want to have a look at. That's covering quite extensively what the CRS benchmark is covering. It includes all the controls, the Docker extensions, and it's giving you a guideline how to build a profile. It includes quite a lot of features from InSpec. In specific, the extension, we don't have a Docker resource yet in InSpec, and we have it here available as an extension as part of the profile. As I said before with the SSL example, we have now here Docker resource written, so we can easily say Docker PS, give me all Docker machines, run across that. So that is something that we have seen has great adoption at companies. So we have companies that use that mechanism to cover Oracle databases, for example. And all the software that you have deployed locally is something that you can easily extend here. So if you have home or in-house software that you've developed, there's no chance that we as Chef ship something open source for that because we don't know that application. But you can easily now use the mechanism that we have available to make that happen in your infrastructure and to cover that well. So, and that is also time to place properly where we're heading with InSpec. So currently we have profiles, but you see now as part of the Docker example, we may want to reuse the Docker resource in different profiles. So now going forward, one feature that is highly trusted is the Docker, we call it resource packs. So essentially it's a profile without any test. So it's only offering the extension mechanisms here as we have with Docker, so that we can reuse that resource in multiple profiles. So that will make it really easy to say you offer an application, you also offer the compliance controls to question the system about that. Does that make sense? Sounds good. Okay, thank you very much.